This is Oliver. He is 28 years old and is happily living in his apartment, working as an architect. Oliver lives a relatively balanced lifestyle. He eats mostly healthy, goes for a run every morning, and is known by his friends, coworkers, and family to be a pleasant person overall. So, when he dropped his coffee mug one morning, he wasn't too concerned and thought he didn't get enough sleep. At work, a coworker bumps into Oliver as he's stepping out of the elevator, and instead of receiving a smile and friendly apology, the coworker was given a rude glare and comment. When Oliver got home that day, he reflected on his bad day and thought his outburst at the elevators was again due to being tired and not having his morning coffee. Over the next few weeks, Oliver continued going to work and noticed he was experiencing unusual things. His leg suddenly jerked while he was on his way to a meeting one day, causing him to lose balance and drop all of his papers. At another meeting, he couldn't recall the numbers he was supposed to present and even dropped another cup. On top of all these strange things happening to him, Oliver was starting to feel hopeless and sad and didn't know why. Finally, realizing that there may be something wrong, Oliver does the right thing and decides to go to the doctor. When he gets there and describes his symptoms, the doctor suspects a problem within his basal ganglia. Visit your doctor when you are experiencing symptoms such as involuntary jerky movements, clumsiness, dystonia or rigid muscles, depression, apathy, irritability, aggression, impulsivity, memory loss, and difficulty concentrating. A combination of numerous tests and analyses were run on Oliver, including a thorough physical exam checking for range of motion, a search through family medical history, and genetic testing. When Oliver was called back in, he was told by the doctor he had Huntington's disease. In order to help Oliver understand his diagnosis, the doctor explained how the diagnosis was reached. Testing for Huntington's disease is generally done after an individual displays the symptoms previously mentioned, or even earlier in cases where Huntington's is known to run in the family. Huntington's is a neurodegenerative disease, mainly affecting the striatum, an important part of the basal ganglia. This pathological hallmark is often identified through MRI scans. Let's look at what has been going on in Oliver's brain. Genes are like blueprints for the cells, giving instructions on what to do and how to do it. The letters they use to write and code for these instructions are A, C, T, and G. A process then uses these instructions to construct proteins that carry out all the functions of life. Huntington's disease is caused by a mutation in the Huntington gene, or HTT gene located on the short arm of chromosome 4. In this gene, normal, unafflicted individuals have approximately 20 CAG repeats located in the first exon. The mutation responsible for the disease is the addition of extra repeats, meaning afflicted individuals have upwards of 40 CAG repeats. This essentially means that extra letters are being added to the Huntington blueprint, causing a change in the instructions that has a negative effect on the constructed protein. The Huntington gene, which codes for the Huntington protein, plays a role in protein trafficking, vesicle transport, postsynaptic signaling, transcriptional regulation, and apoptosis. Therefore, when the HTT gene is mutated, these functions are disturbed. Interestingly, the abnormal Huntington protein is expressed all throughout the body, but cell degeneration only occurs in the brain. The reason for this is unknown and has had researchers stumped since its discovery. The increase in repeats doesn't allow the protein to fold properly, affecting its intended function. Some have hypothesized the extra repeats affect the binding affinity of other proteins, as well as regulating calcium homeostasis. The number of repeats has a strong inverse relationship to the age of onset. The more repeats one has, the earlier they can expect the onset of symptoms. The mutation is dominant, meaning only one parent would need to donate the mutated HTT gene to the offspring for the disease to be expressed in the child. This makes it very hard for people with Huntington's to commit to having children, as one parent carrying the disease has a 50% chance of passing it on. So how does the disease progress through Oliver's brain? The mutated form of the Huntington protein aggregates or sticks together within the striatum of the basal ganglia, which includes structures called the caudate and the putamen. As a result, what mainly happens is atrophy or degeneration of the striatum, although cell loss within the cerebral cortex and the global pallidus also occurs. This leads to the most obvious symptoms of Huntington's, which is the loss of motor control. This is because the basal ganglia plays a large role in the modulation and control of movement. The basal ganglia has two pathways, the direct and indirect. which contribute to motor movement and control. These pathways give information to the thalamus, which is the relay station to other parts of the brain. In individuals affected by Huntington's, the neurons in the indirect pathway are affected first. This pathway is involved in inhibiting the messages sent from the basal ganglia to the thalamus. When this inhibition is lost, too much activity is being outputted than it normally would towards the motor control area of the brain, producing excess motor movement and a loss of muscle control. What complicates this matter further, however, is the basal ganglia is involved in many aspects of personality, meaning the disease not only affects motor control, but behavior as well. Atrophy of neurons within the cerebral cortex may also play a role in personality changes and cognitive deficits. Once Oliver finally came to terms with his diagnosis, he began looking into treatment options. Unfortunately, there is no known cure to Huntington's disease, so Oliver's best option is to try and slow down the progression of the disease and attempt to combat symptoms. Treatment aims to control the hard-to-live-with symptoms of Huntington's disease, and this is most often done through medication. Tetrabenazine, or TBZ, is a drug that can be taken at earlier stages of Huntington's disease. At earlier stages, dopamine levels increase, but the expression of the receptors decreases. TBZ is therefore taken because it is a dopamine-depleting agent that is one of the more effective drugs for reducing the progression of the disease and motor control symptoms. TBZ also functions to combat symptoms of depression, which are common in patients with Huntington's disease. Furthermore, people who exercise tend to respond better to treatment than people who do not, so it will be important for Oliver to stay active and in shape. In later stages of the disease, when dopamine levels are low, a precursor called L-DOPA is administered to maintain a good level of dopamine. Long-term use of this, however, could cause unwanted side effects affecting personality and mood. As previously mentioned, there is no known cure for Huntington's disease, and although Oliver will receive treatment, this will only help to slow the inevitable fatal progression of the disease. His movements will become increasingly harder to control and more spastic. Problems with forgetfulness and a noticeable decline in intellectual ability will cause Oliver to eventually leave work. His hands will become extremely shaky as his motor symptoms become worse. At the later stages, he will most likely be admitted into a full-time care facility, as he will be unable to carry out even the simplest of daily tasks and will need constant support. Huntington's disease affects approximately 1 in every 10,000 Canadians. Onset of Huntington's occurs in most cases between 30 and 50 years old. The younger the onset, unfortunately, the greater progression of the disease. The mean life expectancy after onset is 10 to 20 years. Death doesn't come from the disease itself, but complications caused by it, such as pneumonia, organ failure, and other infectious diseases. Huntington's is a debilitating disease, as we can see both for the individual and their family. Hope is not lost, however, as Huntington's research shows marked improvement and possible solutions for the future. Due to the genetic nature and adult onset of Huntington's disease, it has huge potential to be a valid candidate for gene therapy. Gene therapy is when a functioning, non-mutant version of the gene would be inserted into the patient using a virus, and the goal would be to replace the mutated gene with the healthy one. There's also been a large amount of time and effort put into researching specific targeting molecules that would be able to recognize and silence the mutant version of the gene, while allowing the normal version to function. These techniques have centered mainly around utilizing the extra CAG repeats in the mutant as a target. Another technique gaining promise and attention is the use of antibodies, which would bind the mutant HTT protein in the cell, targeting it for destruction. Oliver's case is one like many others out there. For more information, resources, and ways to help, visit www.huntingtonsociety.ca.